Welcome back. We'll continue with the solution of the harmonic oscillator. This time what we are going to do, we are going to add an input to this. So our differential equation is this. So we have a differential equation that governs the behavior of system double dash mx double dash kx is equal to 0. This time we are going to say there is some, and this is the input to the system. So it is a sinusoidal input. Let's assume f naught is 0, sorry, f naught is 1, and let's assume omega. Please remember this omega is the this frequency of the sine wave, means the input, not the frequency that you obtain of the oscillator. So this, suppose this we take as 2. Now let's take m equal to 2 and k. Let's suppose these are the values that we use for this oscillator. All right, let's see the response. How do we solve this differential equation? In this, how do we solve this differential equation when these are, now we can rearrange the terms. So f naught is 1, we can rearrange the terms. Here we can say x double dash mx double dash is sine omega naught t minus kx, and dividing both sides by m, it will be m sine, sorry, it's not omega naught, it's omega actually, omega t minus k by mx. All right, so let's suppose this is the differential equation. Now what is the aim? Aim is to check actually the forced response of this. This is in control theory or network theory, this is referred as the forced response of the system, or particular integral of this system, or the total response here. Actually this is a total response with when the input is also applied. And up to this point we are only checking the natural response, means the response when the input, when the system has some initial conditions. All right, so let's go back to Simulink and see how we obtain this. All right, so let me continue with the same system. So now we are adding a source as well. We are adding a sinusoidal source to this. So this is actually k is actually minus k is minus k is 10. So this is 10 by 2 minus k by m is minus 10 by 2. Now we are adding a sine wave. So to add a sine wave, we click on the library browser and add a sine wave. To add a sine wave, click on the sources, click on sine wave block, add this to the model, switch back to the model, and the amplitude of the sine wave is, if you look at this, we are having an amplitude of the sine wave is 1 by m, and m is 2. So what we can do, we can either add a gain block here, or we can just change the amplitude of this. So let me show you how to change the amplitude. Just double click on the sine wave block, and this is 1 by 2. You can either add a gain block or change the amplitude in itself in the sine wave block. All right, but the frequency is also 2. Frequency is 2 here. Frequency omega is 2. So click on this. Let me show you the response. To see the response, you can see the response looks like this is the response. This is the forced response. Forced response means when the input is non-zero. Now let me increase the simulation time to visualize it better. Let's change the simulation time to 100. All right, so if I run it again, and then double click on the scope. And then you can check. This is the solution of the differential equation when the input is a sinusoidal source. So this is the difference. So from these three examples, you can obtain the solution of any differential equation, any higher order, any differential equation by following the procedure. If you have understood it, please do it like this. Depending upon the order of the derivative, you have to use that number of integrator blocks in this solution. I hope it's clear. Now let me end it here. In the next session, what we'll do, we'll learn how do we use transfer functions in Simulink. All right, let me end it here.